Imagine the darkest corner of space, not a darkness devoid of light, but a darkness born from something so immense it defies imagination, so vast that even light itself cannot escape. We are all familiar with the concept of black holes, but most black holes we've heard about are mere children compared to what we are about to unveil today. If a supermassive black hole like Sagittarius A star at the center of our Milky Way galaxy has a mass of about 4 million times that of our Sun, what would you call an object with a mass 10,000 times greater than that? Scientists call them ultramassive black holes, and among all the cosmic monsters, none are as terrifying and mysterious as TON 618. TON 618 isn't just the largest black hole we've ever discovered, it is the true cosmic devourer. It represents the very limit of our understanding of the universe, and a puzzle that challenges the laws of physics we know. In this podcast, we will dive into true darkness to understand what TON 618 is, how it was discovered, and what its existence tells us about the origin and fate of the universe. The story of TON 618 began with a surprisingly strange misunderstanding. In 1957, Mexican astronomers were surveying the sky to compile the Tonantzintla catalogue, a list of interesting astronomical objects. TON 618 was recorded as item number 618 on that list, but at the time, it was classified as merely a blue-white dwarf, or perhaps an unusually blue star. Just imagine. The most colossal object in the universe we've ever known was mistaken for a tiny dying star in our own galaxy. What a monumental misunderstanding. During the 1950s and 1960s, knowledge about objects called quasars was still in its infancy. Quasar is short for quasi-stellar radio source. They looked like small points of light, like stars, but in reality, they were the centers of distant galaxies, billions of light years away, shining with immense energy. The turning point came in 1970, when a radio survey was conducted in Bologna, Italy. This survey detected strong radio emissions from the location of TON 618, a clear signal that it was not an ordinary star, but a quasar. Astronomer Ulrich conducted observations with the McDonald Observatory and recorded the light spectrum of TON 618. This spectrum was the key to solving the mystery. Ulrich found that the spectral lines of TON 618 showed a significant redshift. Its redshift value was Z 2.219. In astronomy, such a high redshift value means that the object is moving away from us at a very high speed, and more importantly, it is very far from us. From cosmological calculations, a Z 2.219 value tells us that TON 618 is at a light travel distance of 10.8 billion light years. But because the universe is continuously expanding, its actual current distance, or what is called the co-moving distance, of TON 618 is approximately 18.2 billion light years. This discovery confirmed that TON 618 was not a nearby white dwarf, but one of the brightest and most distant objects ever discovered at that time. And this was just the beginning of its incredible story. When we talk about black holes, we are talking about mass compressed to a point where its gravity severely distorts space-time. And the size of a black hole is defined by something called the Schwarzschild radius, which is the boundary known as the event horizon, the point from which nothing, not even light, can escape. For TON 618, its mass was first estimated in 1979 by Ulrich and his colleagues. But a more precise measurement was made in 2019 using a technique to measure the velocity of gas orbiting the black hole. The results were astonishing. TON 618 has a mass of approximately 40.7 billion times the mass of the Sun, or 40.7 billion solar masses. This is a number difficult to imagine. To understand this number, we need to compare it with familiar objects. The Sun, 1 solar masses. Sagittarius A star, 4 million solar masses. The largest supermassive black hole in the Milky Way, 4 million solar masses. TON 618, 40.7 billion solar masses. TON 618 is not in the general category of supermassive black holes, but it is classified into a new type called ultramassive black hole, UMBH, which is a group of black holes with masses greater than 10 billion times that of the Sun. But its true size is even more astounding. The Schwarzschild radius of TON 618 is 1/300 astronomical units, or AU. 1 astronomical unit is the distance from Earth to the Sun. Imagine our solar system. The Sun is at the center. Mercury, Venus, Earth, Mars orbit nearby. Jupiter and Saturn are further out. Uranus and Neptune, the furthest planets, orbit at approximately 30 AU. The Schwarzschild radius of TON 618 is 40 times larger than the distance from the Sun to Neptune. If we were to place TON 618 in place of our Sun, its event horizon would extend far beyond the entire orbit of Neptune. This is a size beyond human comprehension. In terms of light distance, its radius is 0.0206 light-years, or a diameter of approximately 390 billion kilometers. To visualize this more clearly, light takes about 8 minutes to travel from the Sun to Earth. Light takes about 4 hours to travel across our solar system. But light takes about 11 days to travel across the diameter of TON 618 from one side of the event horizon to the other. This is not just a black hole, but a solar system of darkness that is incomparably larger than our own solar system. The existence of a black hole of this size raises crucial questions. How did it grow so large? And why is it so incredibly massive? TON 618 is not famous just for the immense size of its black hole, but also because it is the brightest quasar we have ever discovered. What is a quasar? A quasar is a phenomenon that occurs when a supermassive black hole at the center of a galaxy is greedily feeding on matter. When gas and dust are pulled into a black hole, they don't fall in immediately, but instead swirl around the black hole at high speeds, forming an accretion disk. Friction within this disk heats the matter to temperatures of millions of degrees Celsius, releasing energy in the form of electromagnetic radiation, from radio waves to gamma rays, which means a quasar with exceptionally high luminosity. The luminosity of TON 618 is incredible. Its luminosity is approximately 1.4 times 10 to the 41st watts. This is equivalent to the brightness of our Sun 400 trillion times. Imagine you are looking for a tiny light bulb 18.2 billion light-years away. But that light bulb is so bright, it can be seen from that immense distance. This is truly colossal energy. This immense brightness is a result of the frantic rate at which this 40.7 billion solar masses black hole devours matter. It is accreting gas and dust at a rate close to its maximum possible limit, also known as the Eddington limit. Furthermore, TON 618 is also a broad absorption line quasar, which means its spectrum shows very broad absorption lines caused by high-velocity gas ejected from the accretion disk and moving towards us. This outflow of matter is part of the process by which black holes regulate their own growth and may also affect star formation in its host galaxy. What's interesting is, even though TON 618 is so incredibly bright, we cannot see its host galaxy at all. The quasar's brightness completely obscures the light from all the stars in the galaxy it resides in, making that galaxy appear to be swallowed by the brilliant halo of light. In addition, TON 618 has been found to be located within a massive Lyman Alpha nebula, a colossal cloud of hydrogen gas extending for millions of light-years. This nebula may be the fuel source that has sustained the growth of this violent black hole and quasar since the early universe. TON 618 is therefore like a lighthouse of the early universe, shining with unimaginable energy. It is clear evidence that these monsters of darkness are not merely destroyers, but also crucial mechanisms driving the evolution of the universe. To further illustrate the grandeur of TON 618, let's compare it with other largest black holes we know. The largest black holes discovered in the universe are divided into two main groups, TON 618 and Phoenix A star. TON 618, ultramassive black hole, or UMBH, 40.7 billion solar masses, 1 to 300 AU Schwarzschild radius, relatively high mass certainty, quasar, actively devouring matter. Phoenix A star, ultramassive black hole, 100 billion solar masses, 1,900 AU Schwarzschild radius, lower mass certainty, relatively quiescent black hole at the center of a galaxy cluster. Although Phoenix A star has an estimated mass of up to 100 billion solar masses, the mass measurement of TON 618 has higher scientific precision, making TON 618 still the most massive confirmed black hole to date. The biggest mystery surrounding TON 618 is the growth problem. TON 618 is 10.8 billion light-years away from us, which means we are observing it in the past, when the universe was only about 3 billion years old. The fact that a black hole 40.7 billion times the mass of the Sun could form in such a short time after the Big Bang challenges current cosmological models. Scientists are trying to find answers to: were the black hole seeds in the early universe larger than expected? Did TON 618 grow continuously at a rate faster than the Eddington limit? Are there more violent and rapid black hole merger mechanisms than we understand? The study of TON 618 and other ultramassive black holes is therefore crucial to understanding how the large-scale structure of the universe formed, and the relationship between black holes and their host galaxies. We have journeyed through the story of its discovery, its astonishing size, and the immense energy of TON 618, but its true impact on space-time and on our existence is what is most thought-provoking. Large black holes like TON 618 have interesting effects on what are called tidal forces, which are forces caused by the difference in gravitational pull acting on an object at different distances. For smaller black holes, such as those formed from the collapse of stars, the tidal forces at the event horizon are so intense that they can tear an object falling into spaghetti-like strands, atom by atom, instantly. This phenomenon is called spaghettification. But for an ultramassive black hole like TON 618, the situation is entirely different. Because its Schwarzschild radius is so large, the gradient of gravitational force at the event horizon is relatively small. What does this mean? If you were unlucky enough to fall into a small supermassive black hole, you would be torn to pieces before even crossing the event horizon. But if you fell into TON 618, you might feel nothing at all as you cross the event horizon. The tidal forces would be so weak that you could pass the point of no return with your body still intact. Of course, not long after that, you would approach the singularity, the central point of infinite density, and that would be the true end. But the journey through TON 618's event horizon is much smoother than that of smaller black holes. This is the fascinating paradox of the universe. The larger the monster, the gentler the entry into its domain. TON 618 is not just an astronomical object, but the largest physics laboratory in the universe. It helps scientists test Einstein's theory of general relativity in extreme conditions that cannot be replicated on Earth. The existence of TON 618 and other supermassive black holes prompts us to question the nature of reality and the limits of human understanding. It reflects our insignificance compared to the grandeur of the cosmos, but at the same time, it emphasizes the immense power of human intellect and curiosity, which can unravel the mysteries of the universe billions of light-years away. These black holes are symbols of emptiness filled with unfathomable energy and mass. They remind us that, in the deepest darkness, there are still laws and phenomena more complex than we can imagine. The study of black holes is therefore not just the study of physics, but an exploration of the boundaries of knowledge and an acceptance of the mysteries that still exist. It teaches us humility and to open our minds to the limitless possibilities of the universe, that there are things we don't know and may never fully know. But the pursuit of knowledge is an endless journey, and every discovery, whether small or large, is a crucial step in understanding ourselves and our place in this vast universe. TON 618 is a reminder of the vastness and mystery of the cosmos. It shows that even in the early universe, there were mechanisms capable of creating structures so immense they defy our comprehension. Its existence forces us to re-evaluate our models of galaxy and black hole formation. It is evidence that there may be many other ultramassive black holes hidden in the darkness, awaiting discovery. As we look up at the night sky, TON 618 may appear as just a faint point of light, 18.2 billion light-years away, but in reality, it is a center of power, shining with the energy of 400 trillion suns and a gravitational abyss 40 times larger than our solar system. It is TON 618, the ultramassive black hole, the cosmic devourer, and a mystery still awaiting answers from humanity, and a priceless lesson that nature offers us about the grandeur, the mystery, and the beauty of the universe. Thank you for joining us on this journey into the realms of darkness and light today. If you are amazed by the story of TON 618 and wish to explore other mysteries of the universe, don't forget to subscribe to our channel. TON 618 is the brightest quasar and the most massive confirmed ultramassive black hole, 40.7 billion times the mass of the Sun. Its Schwarzschild radius is 40 times larger than Neptune's orbit. It is approximately 18.2 billion light-years away, and it's a mystery how it grew so rapidly in the early universe. Falling into TON 618 would be smoother than into a smaller black hole, due to weaker tidal forces at the event horizon. Studying supermassive black holes teaches us humility and to open our minds to the limitless mysteries of the cosmos.